Good to go.
All right. Well, welcome everyone. Thanks for joining our Tech Talk this Friday through the Tech Academy. And also happy early Halloween. And today we have a special guest, Mounir Shita, who is the founder of Global Economic Alliance, and they're going to talk about artificial superintelligence. So thank you for being here and take it away.
All right. Well, thank you for having me. Superintelligence. The three things I'm hoping to do today is to kind of give you an idea of why I think superintelligence is a must for the human species. Kind of where we are on our research, keeping it really, really high level. Just kind of convey the kind of concepts to give you an idea of what path we're taking, which will leave you with big holes, but I think that's okay. And kind of maybe leave it a little bit of cliffhanger at the end with tell you what if my team is successful at that, which it's a big if, what we would want to do with it to change life on our planet. But let me introduce myself first. Let's see if this one works. Wait, I am not sharing screen, am I? Let's see here. There, I think I'm sharing screen.
Yeah, looks good.
Okay, perfect. Okay, so let me introduce myself first. My name is Mounir Shita. If I can get this to work. Yes, my name is Mounir Shita. I lived in the US for 23 years. I've learned that that's not an easy name to pronounce. You're welcome to call me Mo. But I grew up in Norway. I grew up being very much inspired by Star Trek. Not necessarily the episodes themselves, but the purpose of the show, what Gene Roddenberry really wanted to push, to inspire people to create a better future. I've been in AI since the 90s, so it's not something that I just discovered a couple of years ago, but I've always been interested in making machines intelligent. And I've also been in the startup world. Today I have a little bit of a side gig teaching kids at Outschool. And one of the things, so I teach everything from AI to super AI, especially on the super AI stuff. I teach everything from ethics to morals to good and bad and how it could affect the future. But one of the things that I really like about teaching these kids is about my research is that I have to understand my own research really well to be able to translate it into English for these kids to understand. And so I'm hoping to benefit from that today as well by using English to explain where we're at on our research and not, some scientific lingo. All right, so I want to start with this cover of the New Yorker back in 2017, which I think captures a lot of people's fear with the day machines become more intelligent than humans. That, one day machines going to take our jobs and we're going to have nothing more to live for, and we'll sit on the side of every corner, I guess, and collect what looks like spare parts. Which I agree, super intelligent will likely take all of our jobs. And I don't care who you are. I don't care if you're a programmer, or a lawyer, or a doctor. If a human can do it, machine can do it, they can probably do it better. But I don't necessarily agree that humanity will no longer have a purpose. In fact, I think we will have better lives if we don't have to wake up every day chasing a wage to pay our bills. But I still think this cover is amazing, and credit to the artist who came up with this. So here is I always like to talk about, I always like to dig to find the most fundamental questions you can ask. And the most fundamental question I always start with teaching these kids is, why do we not have super AI today? I mean, we've sent a man to the moon, men, plural. We sent many people to the moon. We have 2 spacecraft that left our solar system. We have planned out or discovered an entire human genome. We have done so many amazing things. So why haven't we taken an inch towards superintelligence? Now, people do think that we have taken very big steps towards human intelligence. I tend to disagree with that. AlphaGo might be one of the most powerful AI machines that exist today, but AlphaGo doesn't stand a chance against you if you play tic-tac-toe, because it was specifically programmed to play the Go game. So the idea of intelligence and thinking and planning and all that kind of stuff, we haven't really taken a step towards. So why is that? Now, here's the thing. Every scientist is going to have their own opinion on this. So I'm not going to give you an answer that represents the entire research field. I can only give you what I believe and what has fueled me in my research. So don't take anything I say today as this is what every single scientist believes, because that is not going to be the case. But what I believe, to understand where I'm coming from, first of all, we have to go back to 1978 to Dr. Vernon Mountcastle, which you may or may not have heard of. He was a neuroscientist who published a very, very controversial paper. In fact, it was so controversial that his two the research partners refused to put their name on it in case it would ruin their careers. But in it, he proposed a couple of things. He proposed that the cortex, which is like the part of the brain that makes all the decisions, uses the same process no matter what decision you're making. It's not like one decision to decide, it's not one process to decide what food you're going to eat, one process to decide how to write your software code. It's the same exact process. And with it, he proposed that your inputs to your cortex, doesn't matter if it comes from your eyes, from your ears, from touching, all of that somehow, somewhere gets essentially normalized so that the input looks the same for this process to take place. Now, I didn't actually, when I started my research, I didn't actually jump into Mountcastle. I actually never heard of the guy. I heard of him through a book that Jeff Hawkins wrote. You might have heard of Jeff Hawkins. If you're at my age, you might remember Palm Pilot. He founded that company, made a bunch of money, and decided to pursue his passion, which was the human brain. So he started the Redwood Neuroscience Institute, which is now part of the University of California. And he also started an AGI company called Menta. AGI, by the way, stands for Artificial General Intelligence. So he is really into trying to figure out how does the human brain work and how can we replicate it into a machine. And in his book, he said that if Dr. Mountcastle is correct, it literally means that the cortex is running a single algorithm. One algorithm that allows the human brain to learn everything we're learning and figure out how to do stuff in life. Now, that's a big deal. And I know there's probably a bunch of coders in here, so let me visualize it the best way I can. Imagine writing a function where the input to the function is whatever observations from your environment, and inside the functions, you learn about these observations, you understand them, and you figure stuff out. That's supposed to be stuff, not any other word. And then returns some information on how to do stuff in the real environment to move you towards achieving your goals. And I'm not saying write this function for a specific goal. I'm saying write this function so that it can learn anything that's possible to learn in the universe, figure out anything that's possible to do in the universe, and then kind of control the actuators in real life to make changes in the environment to move you towards the goal. If you can build that single algorithm, life on our planet will very likely change. And to put it in a different way, a professor at the University of Washington, Seattle, in his book, he wrote that, by the way, he calls it the master algorithm. If it exists, and by the way, we do not know if this exists. No one knows if this exists. No one has actually built one of these things. But if it exists, the master algorithm will be able to understand all the knowledge in past, present, and the future. And continuing on, he was saying that this algorithm will be the greatest scientific advancement in human history, and we won't be able to imagine how life will change with this algorithm. What we do know is that this might sound great if we use it correctly. But it's also a fear for others. So I wanted to kind of give you some of the views that I have on fears, based on what I've experienced personally. But it's very different than what you might have heard people like Elon Musk is pushing, that we're going to have killer robots that's going to end humanity. Let's go back to 2017 with Vladimir Putin. He, in a public speech, said that AI is the future, not just for Russia, but for all of humankind, and that whoever leads in this sphere will become the ruler of the world. Now, once this broke, clearly because he used the words ruler of the world, every news agency in the world reported about it, including here in the United States, from Fox to CNN to MSNBC. Definitely not a partisan thing. Everyone reported about it. A lot of the media said that he was talking about building up the AI industry in Russia to compete against America and China. I know for a fact from U.S. intelligence, that is not what U.S. intelligence believes. That what they believe, he said, is essentially whoever builds super AI first will rule the world. And which kind of goes to what Pedro Dominguez said, that if you kind of build super intelligent, it will change the future so much. So volume. Oh, you guys can't hear me?
Yeah, we can hear you.
Okay.
Sounds good.
Okay. Then I'm not. I know Lisa has some problems hearing me. Okay. So what Pedro Dominguez said is, whoever builds super intelligent, once we have super intelligence, it will completely change how we live. The thinking here is that whoever builds it will have a big say in what the future is going to look like. And he had this speech September 1st, 2017. The news broke September 4th. I believe that was a Friday, and then 4th was the Monday. And on the 4th, every news agency reported about it. And of course, Mr. Elon Musk had to weigh in on this. So when Verge tweeted a link to their article, Elon Musk said that competition for AI will likely cause World War III. So let me kind of rephrase what the thinking here is. Imagine a small country like Andorra. If you haven't heard of Andorra, that's how small they are. You have to actually zoom in between the borders between France and Spain to even see Andorra on the map. Imagine a country like Andorra building the first superintelligence, deciding that they're going to use it to change how the world works, and they're going to decide how the world's going to look like in the future. Will China, Russia, and America and other powerful nations just sit back and say, yeah, go ahead, do it, Andorra, show us? Probably not. So that's kind of what he was referring to. He also said that if a company builds it, then the government will just come in and take it from you. And I know Elon Musk doesn't have a lot of positive things about AI, and this might sound like something that could happen in countries like Russia and China, but I also know for a fact from real experience that Department of Defense in the United States has superintelligence as the #1 threat to U.S. national security should U.S. not control it. Meaning that if you get close to it, you will have federal agents at your door. That's not an if. You will have federal agents at the door. And this is why a lot of people call this the modern day Manhattan Project. Difference is, back in the day, during the real Manhattan Project, you had to have physicists working in big government, facilities, building these nuclear bombs, things with writing code. Is you can probably do it on a $200 laptop from Best Buy, and anyone can do it. So that one single algorithm, if it exists, and you can build it, it suddenly becomes the most powerful thing humanity has ever built. And so it's not just some dream a scientist has, it is an actual thing that people either welcome or fear, depending on who builds it. And a lot of scientists believe that you can compare the single algorithm to the theory of everything in physics. If you're not familiar with the theory of everything, is this dream that we can build, we can develop a theory that explains everything in the universe. And of course, we don't have that today. I tend to disagree with this. This is where I kind of start going away from more mainstream thinking in superintelligence. I don't think it's a single algorithm. I think that single algorithm is an application of a theory. See, the problem, going back to the original question, why don't we have superintelligence today? It's because we don't know what intelligence is. Now, that might be a surprise to a lot of people, but there is no scientific definition for intelligence. Yeah, you can go to Wikipedia and it'll tell you that it's something to do with planning and reasoning, but we don't have a scientific definition for intelligence. And if you can't explain it, how can you build it? So University of Oxford has done this couple of surveys asking scientists in this field, what do we need to focus on to get to general intelligence or superintelligence? And this is the responses from the majority of, or not the majority, from whatever scientists participated. You could say, you don't have to just give one answer. That's why these numbers don't add up to 100%. But look at the top four. They're all derivatives of the human brain, neuroscience, human thinking, human mindset. Not one single line in there has to do with figuring out what intelligence is. Not a single person, at least on this survey, responded back, we need to know what intelligence is. And that, having been in this field for over 15 years, that surprises me. There's a very small group of people who have actually tried to define intelligence. And here's one. You might recognize the first name there. He was a co-founder of DeepMind. Long before DeepMind, Legg and Hutter published this paper to try and define intelligence. Now, I both love this paper and I hate this paper. I hate it because I don't think they did a really good job in following scientific processes. They're using informal definitions from people in the world of psychology to try and extract something to turn it into a mathematical equation. I do believe that if you really want to figure something out that we don't know what it is, you should kind of take the lead of people like Einstein that used imagination and thought experiments to envision stuff. The reason why I like it is because as far as I know, it is the first paper that actually said, hey, we got to figure out the intelligence. And they literally start the first sentence with a fundamental problem in AI is that nobody knows what intelligence is. Now, there are some other papers in AI that tries to come up with a theory of intelligence. The latest one I read is from a professor at the University of California, where he has a theory that is very close to the theory that we built, but with one difference, he tries to explain it in biology. But his paper is, in my opinion, a really, really good paper. But I'm going to give a lot of credit to Shane Legg and Marcus Hutter for even telling this industry that we got to focus on intelligence, defining it. And unfortunately, we still remain in the minority, of scientists who want to really focus on developing a theory. So let's get to my research. I'm just going to jump straight into it. We define intelligence as the process of changing composition of space-time, and I'll tell you exactly what I mean by that in a second. But it probably doesn't make a lot of sense. Actually, I've never met anyone who just reads the short definition and instantly understands what I'm talking about. But I wanted you to focus on one thing. The word space-time, it puts it in physics. Part of what I wanted to do was to really dig into the as deep inside the stack of reality to kind of figure out what is intelligence. And where I ended up was in the world of physics. It was not in biology. I tend to believe that biology is an application of intelligence, not really the definition of intelligence. So let me tell you what I mean by this. Here's a thought experiment. Let's say, I think most people agree, I think pretty much everyone agrees, that the more intelligent you are, the more efficient, the better you are at achieving more and more complex goals. So let's just take a super simple goal. You're supposed to move that coffee cup from the left side of the screen to the right side of the screen, and you do it. And it's not very hard. But the first question we asked ourselves is, well, now that the coffee cup is on the right side, how do we describe that we have achieved our goal? Or how do we describe the difference between the coffee cup being on the left side versus the coffee cup being on the right side? Because if we're going to measure intelligence and their ability to achieve more and more complex goals, we've got to be able to figure out the differences between before you achieve the goal and after you achieve the goal. And essentially where we ended up is a coffee cup is made out of a bunch of particles, atoms and molecules. And what we did was we changed the location of these particles in space and of course in time. And then we started wondering, is there a goal that can be achieved that doesn't require you to move a single particle anywhere in the universe? And I don't think there is. Anything you want to accomplish, you're going to have to rearrange the universe a little bit. You're going to have to move particles around. You want to build a house, you're going to have to pile up a whole bunch of particles on top of each other. You want to go on vacation to Hawaii, you're going to have to move your body, which is a whole bunch of particles, across over to this island in the middle of the Pacific Ocean. Anything you want to accomplish, you have to move particles around. And that made us start focusing on, well, if we could define every goal, not by where each particle should be located in space, because that would be practically impossible. But if we somehow could focus on this idea of moving particles in space and control the movement of these particles so that we can control the outcome, that could be a general way of describing intelligence. Now, to do this, if I were to move this cup from here to here, I obviously have to bring my hand up, grab it, push it. And that's all a bunch of cause and effects. So how we kind of are looking at it is, we need, to plan out how to achieve a goal, what you essentially are doing is you are planning out a chain of cause and effects. And the better you are at planning it out, the more likely that chain is going to achieve your goal. Now, people usually manage that chain. Let's say it's going to take you 2 weeks to achieve a goal. For the next 2 weeks, you're going to be managing that chain to make sure that anything that affects your the pre-planned chain, that you adjust for it. But that's how we define intelligence. Essentially, I don't like to use the word rearranging in science, but just in plain English, we define intelligence as the process of rearranging the universe a little bit, the way you want. And going back to, let's say, the theories of Einstein, we know that if you had the knowledge of every single cause and effect that could ever happen in the universe, you could describe the entire universe. Not only describe it, you technically would be able to control the entire universe. So part of what our thinking was, okay, what if we create a machine that can learn cause and effect and use that knowledge to start building four-dimensional models of the universe? When I say four-dimension, I mean slice it up so that every slice is a moment in time. And what we do know is that a cause and effect, if you have a cause that happens in one moment in time, the effect doesn't happen in the same moment. According to Einstein, the fastest you will ever see an effect has to follow the rule of the speed of light. Cannot go any faster than the speed of light. So if we could create a machine that could learn cause and effects, it could start building more and more detailed models of our four-dimensional universe. Not the entire universe, but the little corner of the universe that each of us live in. And you can have the machine start much higher level. For example, I type in a phone number, that's the cause. Your phone rings, that's the effect. But in between, there's a whole bunch of other cause and effects. But you can have the machine start learning the cause of dialing someone. The effect is the other phone ringing. And as it learns more and more cause and effect, it can start learning about the reason why dialing a phone causes the phone to ring, which is a whole other set of cause and effects. If you have a model like this, what you could do is take another moment in time further down the road and embed any goal you want, assuming you can define the goal in pure cause and effect language. Build a house, find a cure for cancer, it doesn't matter as long as you can define it using cause and effect. And then the machine's job is to figure out what cause and effect chain or causality chain has to be built to make sure that that goal gets realized in the future. So it has to continuously have this four-dimensional model of reality and constantly be updating it based on sensor inputs that tells it what's going on in the world. But if you could build something like that, I think you can build a single algorithm that can manage cause and effect models and figure out what needs to be done in the real world to realize whatever you want to realize in the future. And we did end up turning it into a mathematical equation, an equation that actually let us build code around to manage cause and effect chains. I'm not going to go through the equation. That will take way too much time, and it's probably way too boring. But this is what we built so far. A machine. So everything inside, if you remember that function I showed you earlier, everything in that square is essentially inside that function. You pass it information about reality. It turns them into, every observation gets listed in this, what we call temporal queue. We know that an effect comes after cause. So let's say observation 16 is the newest observation. Observation 1 is the oldest observation. So if we pick one, say observation 7, and we call it cause, by the way, every observation is a cause for something. But if we pick observation 7, and we're going to say, hey, that's the cause, now we need to figure out what the effect is. Well, we know the effect is going to be somewhere between observation 8 and observation 16. We may not know which one it is, but the more we observe observation 7 in the future, the more likely we are going to be able to filter out what is, or figure out which other observation is the effect of that, cause. And so the more we learn, the more we are building a better and better four-dimensional model of reality. The more goals you give the system, the more it can start planning out what cause and effect needs to happen for us to achieve the goal, and then report that back out to some actuators that do something in real life. And then, of course, we sense it. We sense, again, the changes in the environment and learn from it, so we can learn if what we did was correct or not. So what we have built so far doesn't actually do anything in real. It can only tell other things, other systems, what to do in real life. And it's kind of like you walking towards a closed door. If your brain sees the closed door and you need to get through it, it's not like your brain jumps off your head and opens up the door for you. Instead, what happens is you walk towards the door and your brain tells your body parts, so your legs to slow down, your arms to get up and open up the door. So your brain actually manages your body parts to control the environment. And that's how we decided to do this. If this is the brain, we decided to put the brain on the internet, which means that in theory, any device connected on the internet, TVs, cars, machineries, anything, including software, if this brain could control all these things, make them work in concert to achieve goals, I think we can start building something that, or start getting something that gets us closer and closer to super intelligence. Now, the one thing we did fear the most about this is if this works out, the first thing is who controls this single centralized brain? And that was a fear to us. And privacy was a fear to us as well. I mean, for this to work, it has to learn a lot about you. So what we decided to do was to decentralize the whole thing. These clouds represent what we call personal clouds. Anything these devices learn about you, all the cause and effect it learns about you, essentially get stored in the personal cloud. All the details get stored in the personal cloud. Some or all of it really depends. And by the way, you can host your cloud anywhere you want. So you're full control over it. It's open source. You can rebuild it the way you want. And then that information goes to an AI algorithm. Again, it's something we want to decentralize. So anyone who wants to run an AI algorithm can do it from their home computer, or the computer at their home, or whatever. But we didn't want a single piece of the system to be controlled by a single company. I think that just is a recipe for disasters in the future. So that's kind of how we built it. To give you some examples of what we've achieved so far, here's 4 screenshots. The first one, we worked with some teachers at the Beacon School District to teach this AI to read and write. The question that came in on text message was, is everyone there? And if you've ever worked with natural language processing, you know that that is a question that is almost impossible to answer. But because we build these 4-dimensional models, our AI was able to respond back and say, everyone is here except for you. The second one, we did set up a little bit of fake data to make this happen, but we had a dinner party, found a recipe, went to a grocery store. The AI brought a shopping list app on the phone. We went out in the store, found all the stuff we needed. Milk was a part of the recipe, but the AI put this triangle up there and said that one of my guests is lactose intolerant and I should not buy milk. Our AI has learned. We had a stand at CTIA, which is one of the wireless conferences in Vegas, and for it we prepared a single use case where anyone could download it on their phone and go out to restaurants, and this AI will actually learn what you like, what you don't like by just observing you. So no matter what restaurant you went to, eventually it will be able to go out on the internet, find the menu, and only show you the part of the menu that I believe you'll like to eat. So that's the current result. But here's the thing. Right now, it's only learning cause and effect from phones, which is not enough to make it actually really, truly super intelligent. And so what we want to do and expand into the future is, can we get this thing to learn cause and effect at the galactic level, telescopes and whatever is out in space, in everyday stuff and in the quantum level? If it can learn cause and effect at every single level of reality, that's when we think this might end up, we're optimistic that this might actually end up being real artificial intelligence, but it's going to take us years to get to that point. But we do think we're on the right path. And the question then becomes, well, what do we want to use it for? And the first thing people say is like, oh my gosh, you can build this product, make a whole bunch of money, build a big company. That's not what we want to use it for. I don't think building a product to make yourself rich is really how you change the world. So again, as a Trekkie, going back to kind of what Star Trek was showing about the future, what we decided to do was to focus on this thing called Great Filter. You may or may not have heard of this idea of the Great Filter, but the idea is pretty simple. Most civilization essentially collapse in the most civilization in the universe, not as in alien races, collapse in the universe because we all get to some point where we do something wrong and we blow up the planet. The question then becomes, where is humanity on path to blow ourselves up? I don't know if anyone would say we are safe. I think most people will agree we are not safe. And I personally don't believe that this wealth acquisition economy we're living under is going to help us actually get through this great filter. We've known, there was an article on CNN today that LBJ had a first memo about global warming, showing that global warming was real, and we've done nothing since because it's always been too expensive, or there's not enough profit in something. And so unless we can get away from wealth acquisition, I have a feeling we're going to have a hard time getting through this great filter. And that's what we decided. If we are successful in our AI research, that's what we want to use it for, which means our dream is, and we have ideas on how to do this, we want to push the monetary system way deep into the technology stack. Can't really get rid of money, but we could get rid of it on the human level. We got to get rid of the politicians who create laws that regulate the global economy, but in such a biased form that it benefits certain people. Got to get rid of that. And use this AI, not, controlling the global or regulating global economy isn't just about money. I mean, the economy is really not money. Economy is essentially a fancy word for resource management. And resources is everything from an Uber ride to an airplane to water to food, including knowledge. So having an AI that not only helps us discover knowledge, but actually presents us this knowledge when we need it to solve certain goals. That's how we think we could actually make a huge dent in the future of humanity. This will never happen, by the way. No matter how successful we are, this will never happen in our lifetime. But that's our long-term goals. And that's my thing about AI.
All right. Really well presented, Mo. And anyone who has any questions can definitely unmute their mic and ask Mo questions. And you're welcome to ask questions in the chat as well on the right-hand side.
It looks like there's also some questions in there already. It looks like someone just raised their hand.
Yeah. Hey, Mounir. This is
Hey,
Flo.
yes, how are you?
What's up, my friend? I'm doing good. As part of Mounir early
we went
life
to college
together. College
yes.
together. Hey, I love the aspiration, the vision of like what the AI can do. And do you think though that in order for this to happen, you're going to have to give out a little bit and let some folks make money with this? I'm just thinking, I'm in manufacturing, for instance, and I could see how cause and effect can really come into play for doing processes in the manufacturing. So someone will have to make some money, and what would happen is your algorithms will learn more cause and effect to get to that vision that you have. Do you think sometimes your company might have to go through some kind of corporate route and let some folks make some money before you get to the end goal that you have in mind?
Yes. Look, you can't change a system from the outside. You can only change it from the inside, which means you're going to have to abide by the rules of how things work today. Pretty simple. So absolutely. Now, for a variety of reasons that I can't talk about, we were forced to shut down our last company. We haven't given up. So we're launching now as a not-for-profit organization, where we will actually be giving, assuming we have a little bit of more work to do, but we are doing a huge upgrade to the algorithm. But what we're going to do is we're actually going to give it away for free to anyone who wants to use it. So we do want people to use it. And we clearly have to make money somehow to be able to run this operation. But our goal, our mission is not to become a profitable entity.
And
so yes,
in return, you want to have more cause and effect relationship. Is that correct? Yeah.
Yes. So I'm just reading the last message here. Seems like a much needed step is coming to some agreement as a definition, a discrete set of definitions as to what is and what isn't intelligence. Well, so there is no agreement on what intelligence is. What I presented to you is going to be a part of a paper that we're going to make available, I think, early next year. So far, we've been testing it out with a bunch of scientists, kind of finding the holes in our theory before we actually turn it into a real paper. And I think we're at the point where we're ready to turn it into a real paper. The thing is, just because we publish a paper does not mean that is now a fact. It has to be peer reviewed. People have to agree, disagree with it, find holes, poke holes. Are we getting closer to defining intelligence? I don't know the answer to that. What I do know is I think before we can define intelligence, I really hope we can convince the entire research community that we have to define intelligence. Is this process similar to linear regression? No, it is not. It is. I'm trying to think of something I can compare it to. We're trying to build a puzzle, and each one of these cause and effect pairs is a puzzle piece, and we're trying to figure it. No, it's. I'm just going to leave it at pretty simple. No, it's not similar to linear regression.
The reason I asked that question was just, it seems like you're depending on repeat observations of something, and
Yes.
you adjust as needed depending on feedback from your repeat observations. And I was just flashing back to my grad school days when I was enamored by the whole notion of linear regression, that if you have the right variables and you weight them properly, you'll be able to determine outcomes.
Well, and that's where the biggest difference is there is no determined outcomes, no matter how correct your cause and effect is, because the outcome depends on, let me put a real example here. Punching a guy at the bar and punching a cop has, same action, two very different outcomes. And so there is no determinate outcome on anything. And what you're actually going to have to do is, not only do you have to sense back the outcome of what you try to do in the real world, but you actually have to limit the impact or limit what you learn about that based on context. And it's not as simple as linear regression.
Well, just to push back, if you knew every possible thing that could influence an outcome and you weighted it properly, wouldn't that? I mean,
Yes.
Again, we'll never get there, but
we never. That's exactly. So that's the only reason probabilities exist in science, right? Because we don't know everything.
Right.
So we just have to make a guess based on what we learned so far, and by making that guess is a little bit different here, because the further out you go, the more your cause and effect chain will be affected by things that you don't, like you getting to a meeting time could be, you could run into problems of getting to a meeting in time because a guy you don't know who lives on the other side of the street decides to drive drunk and cause an accident on the freeway that prevents you from getting to your meeting on time. And so, that's what we have trouble is we don't know everything that's going to happen. But going back to what in the beginning, before you started recording, you asked if you need quantum computing for this stuff. That's where I think we need quantum computing, because the more computing you have, the bigger these 4D models can become, and you can actually become very, very good at determining the output or the outcome of certain things. Part of what we're doing right now to compensate for that is that distributed architecture, where we can have AI nodes, as we call them, or AGI nodes, as we call them, in various geographic locations, only focusing on their locations, and only when you need to have a bigger picture can you merge pictures from various nodes to create a bigger picture, but not have one single node trying to create an entire 4D model of the entire universe.
Thank you.
Looks like there's some new questions in the chat box, by the way.
Yeah. So how does your AI, as you described, decide on the desired outcome or effect? So our AI. So here's one thing a lot of people believe is that once you get to super AI, they will be conscious. They're going to make their own goals. That's not how I look at it. I don't think there's a link. I don't think I'm sorry, I don't think their intelligence and consciousness goes hand in hand. First of all, I don't even know what consciousness is, and just like intelligence, there is no definition for it. But so in our system, goals have to be given. We on our code allow the AI to derive goals based on what it's observing, but it can't actually put goals into its 4D model. So the only thing our AI does is once a goal is set in this 4D model, it actually tries to come up with a whole bunch of different cause and effect chains to try and figure out which one of them could actually lead to achieving a goal. In the beginning, when it doesn't really know you well enough, it will always ask you for permission. Should I take, should I turn left or should I turn right? Once it learns more and more about how you make decisions and becomes pretty confident that you're going to make certain decisions, it will start making those decisions for you. But it always looks at, is this the best path to achieve a goal without precluding other goals in life? So it's always about goal management. But, and one more thing actually I want to say on this. I know there's a lot of complaints that deep learning, you can't really tell. I mean, the European Union even put a law out on this. We can't really tell how it came to this decision. With what we're doing, we can actually give you an entire log file to tell you exactly why the AI believes that these 10 actions is the right actions to take. Pretty amazing space awareness vision system.
Yeah, I just made a comment, Mounir. Like, if in your space time, space is super important to me. It's like you got to be able to identify all those objects, like your cup of coffee, that bench, and then you has metadata behind, and then you want to go from here to there, and so it's an amount of amazing data. Like your example of punching the cup versus punching an annoying person at the bar, you're just gonna need to know that he's a cup and all this. You recognize that object.
Yes.
You got the metadata behind.
But here's one thing though. So far our AI does not use any vision system at all. It uses all kinds of other sensors. It senses Wi-Fi, it senses GPS, it senses a whole bunch of things. I think what's really important is, like, a lot of times we assume that the senses we have as humans is what an AI needs. And that's not necessarily true. I do agree that at some point we need a vision system. But the whole purpose of making, the whole purpose of intelligence is to sense the environment. What type of sensing is almost irrelevant as long as it's good enough sensing. So it doesn't have to be, eyeballs or camera. Although I do think that's important. Let me tell you one thing though. On one of our tests we did a few years ago, we wanted to test if our AI could abstract the idea of home to mean a location. A super simple way of defining home, right? Just a location or a subjective location, like your home is different than my home. And so we assumed or hoped that once it had learned home, and we looked it up on our database, it will say home is a location, but undetermined until you have an observer. And it turns out that it had defined home as a location and set of Wi-Fi signals, both of which are undetermined until you have an observer. And first we thought that was a bug, but then we realized that if we humans could sense Wi-Fi signals naturally through our skin, because Wi-Fi doesn't travel very far, we would know when we're home. And started realizing that all the knowledge we have acquired is all described using the human 5 senses. But the machine doesn't have those 5 senses. The machine has, a gazillion more senses, and it will be able to describe knowledge in ways we could never, ever imagine. And I think that is one of the most exciting things about AI, being able to look at problems from a completely different perspective. So I'm not too worried about, now we're not using vision system at all today, and I'm actually not in a hurry to put it in, but I do believe we need to put it in at some point. Sounds like what statistics is all about. Yeah, I'm not going to argue with that. I will say fancy statistics. What do I think of a human-centered approach to defining AI? Is that what the question is? I hate it. I absolutely hate it. And let me tell you why. We are, if you look at the biggest part of this research community, we are so tunnel visioned on, I think the CEO of DeepMind said that the only evidence we have of intelligence is the human brain. And I disagree with that. My cat doesn't know how to open up the door. He might not know how to, he knows how to get up and pull the door handle down and open that door. He might not be able to make code or write code, but my cat is intelligent, less intelligent than humans. I think the problem we're having is we're so focused on humans. I think what we need to do is to have a definition of intelligence. And by the way, I'm not familiar with the EU's definition here, but I think we need to have a definition of intelligence that that can describe intelligence for any life form in the universe, any life form, not just human life. I think the human brain is nothing but an application of intelligence. But again, I am not familiar with the EU's definition.
All right. Any more questions for Mo? All right. Really well presented, Mo. We appreciate you coming out. That was a great presentation, really intelligent, and kind of definitely shows where AI is going. I do like the cause and effect and the and with the four dimensions. Maybe you can model that in a tesseract. But yeah, thanks for coming out, and thank everyone else for coming out to our Friday talk.
Yeah, thanks everyone. Also,
Thank
I
you.
put Mounir's LinkedIn in there. If you ever like to contact him about this talk or anything else, feel free to reach out. We're also recording this talk, so you can go back and take a look at it in our Tech Talk playlist on YouTube. Let me put that in the chat box.
I probably
There
should
that
have
is.
stopped the presenting because now it's like picture in picture there.
No worries. All right. Also, next week we have one of our Tech Academy graduates who is going to talk about their experience landing a job within this 5 years and their journey and how now they're a senior developer. So if you're interested in that, I'm going to put that in the chat box as well. But we do have some other topics coming up, and all the schedule for that is on our meetup list. Sorry, I know I'm plugging a lot of links in here. Got to plug everything in, but I just want to thank everyone for joining our Tech Talk through the Tech Academy again. And I want to thank Mounir for doing an awesome presentation. Thank you so much. And I hope everyone has a great weekend.
Thank you.
Awesome.
Thanks, Mo.
joining us.
Really good.
Thank you.
Yeah.
Bye, everyone.
Have a great Halloween, everyone.